Okay, we look at temperature and heat. Now, usually when people talk about temperature, heat, internal energy, they sometimes confuse the words and take them as the same thing. So what is temperature? Temperature is a measure of the average kinetic energy of the particles of an object. Okay, these particles could be molecules, they could be atoms, depending on the object you are dealing with. And temperature in measures in units called Kelvin or degrees Celsius. So we have an object made of a number of particles that are moving. The average kinetic energy of these particles make up the temperature of the object. What is internal energy? Internal energy is the total energy of the particles of the object. Total energy. Okay, so the total energy, meaning that involves both kinetic energy and potential energy. The kinetic energy could be translational, that is moving a straight line, could be rotational. The next concept is that of heat. Heat is thermal energy that flows from an object at a higher temperature to a lower temperature object because of a temperature difference. So we have two objects, object A, object B, and these objects are different temperatures. Let's say this one is at 10 degrees Celsius, this one is at 30 degrees Celsius. Heat will flow from object B. Okay, the thermal energy will flow from object B to object A. That flow of thermal energy is what we call heat. Now, just to make an illustration of the difference between heat and temperature, you must have noticed that if we have, let's say, a glass of water at 100 degrees Celsius and maybe a bucket of water is at 100 degrees Celsius, even though the two are at the same temperature, you will find that this one, if you pour a bucket of water on you, it will burn you more than a glass of water, which are at the same temperature. So it tells us that when an object has more mass, it has more internal energy. So this water, a bucket of water, let's say this is 10 liters and this one is just 0.3 liters, for example. Okay, but both are at the same temperature. This one will burn you more than this because of this, because this one has a higher mass, and so it contains more energy. Now let us look at thermometers. What are thermometers? As you know, a thermometer is a device used for measuring temperature, and all of these thermometers make use of some property we call a thermometric property. A thermometric property is a property of a substance that changes with temperature, and examples of such thermometric properties are a change in the volume of a liquid, a change in the length of a solid when the solid expands, change in the volume of a gas at constant pressure, change in the pressure of a gas at constant volume, change in electrical resistance, and even change in color. So here we have various kind of thermometers. This one is a liquid in glass thermometer, as we shall soon see. This one is thermistor thermometer, and this one is bi-metallic strip thermometers. So there are various types of thermometers, and the thermometers are different because they use different thermometric properties. For example, we have a liquid in glass thermometer that makes use of the fact that liquids expand when heated and contract when cooled. Resistance thermometers make use of the fact that the electrical resistance of metals increases with increase in temperature. A thermistor makes use of the fact that electrical resistance of a thermistor decreases with increase in temperature. So a thermistor is actually made of a semiconductor. and semiconductors have resistances that decrease with increase in temperature. And of course, we have the bimetallic strip thermometer, which makes use of the fact that metals have different expansion properties. They expand at different rates. If we take copper, for example, and another metal, let's say iron, okay, and you heat the two, you supply the same amount of heat to them, the extent to which they will expand will not be the same. So that property is made use of in the bimetallic strip thermometer. Some desired features that a good thermometer should have is that the thermometer should be sensitive. Okay, so the sensitivity of a thermometer simply refers to the ability of the thermometer to quickly acquire the temperature of its environment. That is, it should quickly respond to changes in the environmental temperature. The thermometer should be accurate. In other words, the thermometer should be able to give the same readings as the temperature rises and as the temperature falls. The readings should not be different. So let us look at a particular type of thermometers, a liquid in glass thermometers. These thermometers are made of capillary tube filled with a liquid. Most common liquids that are used are mercury and alcohol. Now the liquid should have some properties in order to be able to be used as a thermometric liquid. One of the properties is that the liquid should have a high ability to conduct heat. Okay, so if it has a high ability to conduct heat, this makes the thermometer to quickly acquire the temperature of its environment. In other words, it makes the thermometer to be sensitive. It should not be a liquid that clings or wets glass. Okay, so if you put, for example, you see water, when you put water in a glass, water sticks to the walls of glass. Such a liquid is not good for a thermometer. And of course, we have that the liquid should expand and contract uniformly, and that makes the thermometer accurate. Here we have some reasons why water is not a good thermometric liquid. We cannot use it. One of them is that water wets glass, so water clings to the walls of glass, so it will make an inaccurate thermometer. Water freezes at 0 degrees temperature, so we cannot measure temperatures below 0 degrees Celsius. Water expands and contracts abnormally. Okay, I'm sure you must have known this, that when water contracts, its density rather decreases instead of increasing like some other liquids. In fact, water has its maximum density at 4 degrees Celsius. That's why ice at 0 degrees Celsius will float on water. So it's less, ice is rather less dense than water, but most substances don't behave like that. The cooler they become, the denser they become for other substances, but water does not behave like that, so we say that behavior is abnormal. Water has a very high specific heat capacity. In our subsequent lessons, we will see what heat capacity is. So with this very high heat capacity, the water takes long to acquire the temperature of its environment, so it will create a thermometer that is not very sensitive. Some special features that we have in liquid in glass thermometer is that they have thin walls or thin glass walls. Okay, we see a liquid in glass thermometer, the walls of the glass are thin. This is because glass is a poor conductor of heat, and so to be able to make the thermometer sensitive, we have to make that their walls to be very thin so that heat can quickly penetrate. They have narrow bores. Okay, the capillary tube is what we call the bore. It is very narrow. This is such that the thermometer should be sensitive. That is, it should quickly increase the liquid in it to quickly expand with changes in temperature, so that we can easily see. The bore is uniform. Of course, the bore is uniform so that the liquid in it should also expand and contract uniformly. A special kind of thermometer that we have is the clinical thermometer that we use in measuring body temperatures. It is special in the sense that it measures temperatures between the range of 35 to 42 or 43. Some are 42 degrees Celsius, some end at 43. It has a constriction. Okay, if you look at a typical clinical thermometer, this one is not well drawn. It has a constriction there. Okay, has a constriction like that. That's why whoever uses it, after using it, you have to fling it so that the mercury should run down to the bore. And why is that constriction there? You know, once the thermometer is out of the body of the person whose temperature is being measured, the mercury starts dropping. So in order to prevent the mercury from dropping before the temperature is read, that constriction is put there. They have a convex stem, okay, convex, like a convex lens, and this gives an effect of magnification so that you can easily see and read the temperature. The bulb is sometimes painted black. Of course, this is to increase the heat absorbing ability of the thermometer or of the bulb. Okay, this end of the thermometer is called the bulb. This part is called the stem. All of this is called the stem. This narrow tube inside is called the bore. Okay, so those are some of the properties of a clinical thermometer. So we have a simple table here that tries to list the advantages and disadvantages of mercury and alcohol as thermometric liquids. So you can pause the video and go through these properties. They will help you in your exams.